Suppose that a, b, and c are positive integers such that a over 14 plus b over 15 equals c over 210. Which of the following statements are necessarily true? Statement 1 states that if the GCD of a and 14 equals 1, or the GCD of b and 15 is equal to 1, or both, then the GCD of c and 210 is equal to 1. Statement 2 is the converse of statement 1, and statement 3 states that the GCD of c and 210 equals 1, if and only if the GCD of a and 14 is 1 and the GCD of b and 15 equals 1. So we need to determine which of these three statements are true, no matter what a, b, and c are, as long as they satisfy this equation. So first we're going to multiply both sides by 210 in order to clear the fractions. So we'll obtain 15a plus 14b equals c. Now let's look at statement 1. We're actually going to disprove statement 1 by finding a counterexample. Now, what does a counterexample to an if-then statement consist of? We're going to need to find a, b, and c such that this equation is satisfied. Moreover, we're going to need the antecedent or the if statement to be true and the consequent or the then statement to be false. So doing so would disprove statement 1. So in order to do so, let's try to think what can we set a and b to be so that at least one of these statements involving the GCD is 1, but the GCD of c and 210 is not 1. And we see that if a and b are both equal to 2, then what happens here? If a and b are both equal to 2, then the GCD of b and 15 is 1. So this satisfies the if statement. But for this choice of a and b, we see that 15a plus 14b is equal to 58. And 58 is not relatively prime with 210. Therefore, the then statement that the GCD of c and 210 is 1, this is false. So because we found one counterexample to statement 1 has to be false. Or in other words, not necessarily true. Now let's look at statements 2 and 3. We're actually going to prove that both of these are true. This will imply that our answer will be E. Now, in order to do so, let's take this given equation involving a, b, and c and simplify it a bit. So in particular, I'm going to take the given equation modulo 14 and modulo 15 so that we can make some statements involving a, b, and c. So if I take this equation that I boxed, modulo 14, then 14b is congruent to 0 mod 14. Therefore, I obtain that c is congruent to 15a modulo 14. Moreover, because 15 is congruent to 1 mod 14, I can actually simplify this a little bit further and state that c is congruent to a mod 14. Now, what does this mean? This means that for any integers a, b, and c such that this equation is true, c has to be congruent to a mod 14. Another way of phrasing this is that the GCD of c and 14 is equal to 1 if and only if the GCD of a and 14 is equal to 1. So therefore, this statement here has to be true. Now, this does not mean the GCD of C and 14 is equal to 1. That does not have to be true. All this says is that either both of these are relatively prime with 14 or neither of them are. Now let's take the equation modulo 15 to obtain a similar statement about B. So modulo 15, we see that the 15a term cancels out, and we are left with C is congruent to 14b mod 15. And because 14 is congruent to minus 1 mod 15, we therefore obtain that C is congruent to minus B mod 15. Now this is pretty much exactly the same as the first statement we got, except there's a negative sign, which does not really impact anything. So we can actually state that the GCD of C and 15 equals 1 if and only if the GCD of B and 15 equals 1. So both of these boxed statements have to be true. So let's prove statement 3 first, because statement 2 is actually a weaker statement than statement 3. So if we can prove statement 3, then we've already proven statement 2. So let's look at statement 3. If the GCD of C and 210 is 1, this tells us that C cannot share any prime factors with 14 and 15, because 210 is equal to 14 times 15. So if the GCD of C and 210 is 1, then the GCD of C and 14 is 1, and the GCD of C and 15 is also 1. Moreover, this is actually an if and only if statement. Now, using what we just determined about C and A and C and B, this is exactly the same as stating that the GCD of A and 14 is 1, and the GCD of B and 15 is 1. So therefore we have proven statement 3 using the given if and only if statements that we derived. Now, because statement 3 implies statement 2, we now know that both 2 and 3 have to be true. Therefore, the answer is E.